Welcome back to another Ramda JS video, and in this video we are going to talk about the function converge. And it's interesting or funny or sad that actually this is a function that I happen to be using surprisingly often, surprisingly high amount of, anyways, surprisingly often, but actually I'm struggling to come up with sensible examples because it's kind of obscure, like it feels kind of obscure, especially when you look at the type signature here. It just looks like, what even is this function? Like it's some crazy obscure madness, right? But it's actually pretty darn useful. So let's just start by reading the definition here, right? Converge accepts a converging function and a list of branching functions and returns a new function, right? There's a converging function, there's a list of branching functions, and then it returns a new function. When this new function is invoked, it was reversed. When invoked, this new function is applied to some arguments. Each branching function is applied to those same arguments. And the result of each branching function are passed as arguments to the converging function to produce the return value. The results of each branching function are passed as arguments to the converging function to produce the return value. So what we're actually saying is that there's a converging function, there's a list of branching functions, and we get a new function back. When we call this new function with some set of arguments or some series of arguments, these arguments are in order passed to each of the branching functions, and each of the branching functions produces results, and these results are then passed as arguments to the converging function. Right? So let's actually, let's jump into Vim here and let's open up our main JS file, and let's just start by requiring Ramda, right? So actually, I just remember that in the docs somewhere, or maybe it was discussed in some of the issues on GitHub for Ramda, there's this guy who said that he usually likes to think about this function as, let me try to remember this, right? I mean, it's like, what we're saying is that we're saying when you say r.converge and you pass some f here, and then you pass some list, and then you pass, if we look at the example here, you can also see that this is kind of the structure that they're calling it in. We're calling converge, and then this is the converging function, and this is the list of the branching functions, right? So let's just say that f here is the converging function, and then let's say we have g and h in a list, and these are our branching functions. Now, what would happen here? Now, so this, or actually, let me say that this is actually, let's actually say this is G and H and W. Actually, let's okay. No, this is, okay, how to make this sensible. A and B, maybe like this, right? Maybe that makes more sense. So C is our convergence function, and then we have function A, and then we have function B, and these two are our branching functions. Actually, maybe we could even do this, B1 and B2. That makes more sense, right? These are our two branching functions, and then we could even say B3 here, and then we have our convergence function. This will in turn give us a function. Right? When we call converge and we pass a convergence function and we pass a list of branching functions, then converge, Ramda's converge will yield a new function for us, right? Stick with me, right? Because converge is actually a very interesting and very useful function. It's pretty cool, actually, okay? So you get f back. Now the question is, what happens when we call, let's assume x is some variable, right? We don't know what x is, but what happens when we invoke f and pass it x? Right? Well, what happens is something along these lines. We're gonna call C, the convergence function, with B1 run with X, or what do we say? B1 applied to X. Wait, X applied to B1, F applied to X. Yeah, B1 applied to X. That's the first argument. The second argument is B2 applied to X, right? The third argument is B3 applied to X, right? I think you can probably see where this is going, right? Pretty cool, right? So we're saying we're going to converge, and this is why it's called converge, right? Converge is the function that we use to reduce the results of applying all of our branching functions because when we've applied the branching functions, we have lots of values, but then we use the convergence function to converge these down into a single value. So you run the function converge, and the arguments that we pass it are essentially the branching functions, each applied to the let's say the value that we pass to the function returned by converge, right? The x in our case. So we run x through b1, we run x through b2, and we run x through b3, and the result of doing this constitutes the arguments that we will pass to c. Right? And then you could keep going here, of course, b4 applied to x and so forth, but then we would have b4 here, right? So this is, again, like assuming there's a function called c, and there's a function called b1, right? But I mean, we're just using some arbitrary variable name and assuming that we already have definitions for these functions. Sorry. Okay, but what's interesting about this is also that not only can we pass x here, we could also pass y and z, let's say. So it's actually, I'm not sure if it's variadic. Maybe we'll get to this in a moment. We'll think about this. But you could, so converge could produce a function that accepts multiple arguments. And I think that's probably, let's see here. The results of each branching function are passed as arguments to the converging function to produce their return value. That's not what I'm looking for. When invoked, yeah, so here. Accepts a converging function in a list of branching functions and returns a new function. When invoked, this new function is applied to some arguments. Each branching function is applied to those same arguments. So the point being that they use arguments and arguments here in plural, not singular, right? So we could actually have x, y, z here that we pass to this outer f, right? Which means that instead of just passing x here, we would pass x, y, z here. Whoops, right? So x, y, and z, and here, right? So now it's starting to look pretty messy, but also you can probably see how it's actually very, very powerful. Like, this is a very condensed way of expressing something which could potentially be very, very complex or very, very like there's a lot of things going on at once, but they're structured in so it makes sense to encapsulate all of this or encapsulate this convergence idea into a single function. So yeah, so expressed differently, let's think about it this way. If we have x, y, and z, as in here, right, then that means that the arity of b1 needs to be 3, and the arity of b2 needs to be 3, and the arity of b3 needs to be 3, and so forth, right? So the arity of our branching functions should be the same, kind of. I mean, you could probably get away with doing something else if you want to use converge to sort of partially apply something, and your result should be a partially applied function or something like this. But beyond that, let's forget about that for a moment. Beyond that, our branching functions should all have the same arity, and that arity should be the same as the arity of our convergence function. And that means that we will then, when we get back a function from running R.converge, we can then apply some number of arguments to that function that we get back, and these arguments will be passed first to each of our branching functions and then to the convergence function. Okay, but this is all a lot of talking, so let's actually now get into looking at some kind of concrete example. Instead of actually using these silly names, let's use some proper names here. So I'm not sure if their examples are actually very helpful, but again, like I can't really come up with a really sensible example myself either. But I guess let's use this. Let's use something with strings that they're doing here, right? So what they are suggesting is that they're saying, okay, let's, what you could do is you could use r.concat. Actually, before we move further, let me comment this out and let's just see, can we do concat with multiple things, right? If I have 1 and 2, we can of course concat that to 3 and 4. Sorry, console log, let's console log that. So, and then I'll map a keystroke to running node on this main.js file, okay? So we get 1, 2, 3, 4, right? So that we can do, but can I pass multiple arguments here? I'm not sure about that. No, we can't. Okay, so it's actually just 2. So I would maybe like to have, Yeah, never mind. Let's not think about that now. Okay, so let's stick to this. So what we could do is we could say R.converge. Okay, first argument, convergence function. What's the convergence function? Let's use concat. Okay, then we have a list which constitutes our branching functions, the list of our branching functions. The ones they use to upper, which uppercase is a string, and the second one they use is to lower, which lowercase is a string, right? So, and then we could, so from converge here, we will get back a function, and we could then invoke this function, and we could pass it a string. So let's pass hello world. Let's actually do, I'll do underscore hello world so we can see that it's the same. Actually, let's skip the world. Let's just say hello, right? And then let's run this. So we get, similarly to what they get in their example here, we simply get the string first uppercased and then the same string lowercased, right? So think about it. What happens? We're running, I mean, if we could do it this way, right? We are saying to upper on hello, then we are saying to lower on hello, and then we are saying r.concat these two, right? This should be the same thing. Console log, all of this stuff. Let's run that. Oop, sorry, I forgot a comma here. Let's run that again. And then you can see we get the same thing here as we get here. In both of the cases, we get the same thing, because here we've actually just hard-coded it. So what we've done is we've encapsulated this idea of using concat as a convergence function and these two as our branching function. So we're saying take the thing that's passed in and first pass it through upper, or not first, sorry, and pass it through upper, and take that same thing that was passed in and pass it through to lower. And then let's make those, let's consider those two things as arguments, and then let's pass them to concat as each of them as arguments to concat. And you can do really crazy things. So I hope this kind of makes sense, right? But you can do really crazy things with converge. I think, if I'm not mistaken, I mean, it was quite a while ago, but I think maybe we talked about this slightly when we talked about call, because if you go back here in the Ramda docs to call, you can see that we can actually use, yeah, they even mention it, that you can use call when you're working with converge. So let's just read the documentation of call. It says, returns the result of calling its first argument with the remaining arguments. The result of calling its first argument, right, so r.call, actually, if I undo backwards here, what we could do, if we wrap this concat in call, what we could do is we could say call r.concat, that's the first argument, that's the function we want to call, right, and then we want to call it with these arguments, right? That should be the same thing. Yeah, and that's the same thing. You can see we still get the same thing here, okay? So you can use call like that. So we could even rewrite this, or actually, sorry, let's continue reading here. So this is occasionally useful as a converging function for r.converge. The first branch can produce a function while the remaining branches produce values to be passed to that function as its arguments. So what they're saying, and let's even look at the example here, right? They're saying they're constructing a function that they call format, so it's some kind of formatter, and then they're saying, okay, converge by using call. And then they're saying this first thing, the first branching function, is the one that produces the function to which the remaining branching functions will be, or rather, let me restart. The result of running the remaining branching functions will constitute the arguments that are then passed to this first function, right? So here, what are they saying? They're saying, grab the indent property from an object and then call indent n, which is this function that they've constructed here. Yes, so this was clearly unnecessarily complicated. Let's see if we can figure this out on our own, right? So let's see if we can just rewrite, let's say this example. Let's copy this stuff and paste it in here, and let's just say here we use converge. Whoa, converge spelling, my god. Okay, and then here we use converge with call, let's say, and here we just use call. right? So how do we do this? Well, we want to converge, but here we don't want to say, here we want to say r.call. Aha, so here's the key point, right? Think about this. In this scenario, right? Now this is, so let me actually remove this so that this isn't broken. In this scenario, the convergence function is not dependent on the data that we pass to the function produced by converge, right? I'm trying to be careful with my words, but sorry if it gets a bit messy, right? The data passed to the function returned by converge is the string hello, right? Concat is not dependent on that value, right? The convergence function is not dependent on that value. But if it was, we probably have to use call. So let's think about this. What if we had something like, let's say it was more like something like add, right? We want to say add, and we want to add, no, this doesn't really make any sense. Maybe that's why they were doing something like what they were doing. Let's say we're passing in an object here where we have a name property where this person is named John. Let's do that, right? And then we're saying what we want to do is we want to somehow have a convergence function that depends on the name John. And why in the world would we do that? I guess that's the really strange part, right? It's getting a bit funky, but yeah, that doesn't really make any sense. Let's actually read their example, right? Because what they are doing here is that they are saying, well, indent n, let's think about what their indent n function does. They're piping, first they repeat an empty space, they join, wait, r.repeat, what does even r.repeat do? Repeat takes a and n, right? So it repeats something some number of times and returns a list. Okay, let's go back. So they're repeating empty string some number of times, but that's waiting to be applied to an argument. And then they will, right, indent n, right? So the argument that we will pass to indent n will be a number, and that's the number of times that we repeat. So then we have a bunch of spaces, and then you join these spaces. So that's a list, and then you join them up so that there are a bunch of spaces in a string, and then they do some regex where they replace. Let's think about it. From the beginning of the string, capture group. Yeah, this is even, let's actually just try this. It's probably easier than to think about this. No, okay, let's stay in here. Sorry, this turned a bit more complicated than I had imagined. Let's paste that in, console log. I mean, if we just console log this of course gives us a function. But if we then apply this to some series of spaces, we actually still get a function that probably expects another argument. Probably actually, because like if we do length here, we can see that it expects one argument, and if we do length here, it expects two arguments. Actually, I didn't know this, but that's probably why it said F2 here and F1. That's very interesting. But anyways, that's a complete sidetrack. So indent n probably expects some other arguments. So let's just pass foo here. I don't even know what. Yeah. Aha. Okay. 1, 2, 3, 4, 5. Yeah, so it's just indenting. That's a completely useless function. Whew. Sorry, I should have thought about this before. Yeah, okay, so the way they are using it here is that they are saying they're passing an object to format here. And format is a function that uses the indent parameter to indent whatever is under value here, right? So that's why they get back the same string, but they get back this, or they get back the string from value, but they get it back with some number of spaces in front of it. But the key point here to realize again is that the convergence function is dependent on the input here, right? So you can't just say concat some number of spaces with the string, because the number of spaces that you want to concat with depends on what was passed in here, right? So that's why the convergence, or the convergence function needs to be constructed such that it such that it's part of the branching functions, which is why they use call, because the branching functions will actually be past the data, right? So I'm trying to think of whether we should think of some other scenario where we have something like that. So let's say we wanna, anything that does repetition is kind of a sensible candidate, right? Let's say, let's say we have the string hello, like this is our input, and based on the fact that we have 1, 2, 3, 4, 5 characters, so 5 characters, we want to repeat the string 5 times, let's say, right? Hello, 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 right? Is that 5 times? 1, 2, 3, 4, 5. This is completely pointless. I understand, right? But just you're kind of seeing how possibly you could this model something which is kind of remotely potentially useful. Well, I'm sorry, really, it is useful, and I do, if I'm not mistaken, do check out my introduction to Ramda video. I'll link it in the description, where I do a bit of I think I do a bit of parsing on like cryptocurrency data, and if I'm not mistaken, there I do actually make use of converge, and probably in conjunction with call, but maybe I'm mistaken. I think I do use converge anyways. Okay, but anyways, if we would, let's say this is our scenario, right? Input, this is our input, and this is our expected output. Okay, so this is 5 characters. Okay, so how would we do that? So let's call it rep, as in repeat, of course. So r.converge, we're gonna assume that we need r.call, and what is then our convergence, or so this is the convergence function, and here we then specify the branching function. So what will the branching functions be? Well, the converging function should be concat if we need the different strings, but here it's probably repeat, right? So we make use of repeat, and repeat we just checked out here. Wait. Sorry about that. Repeat, we just checked out here, where we could see that there's some character that we're repeating some number of times, and then we get it back as a list. So repeat, we want to call that with the length of the string. Yeah, but actually this doesn't make any sense, because then what we would have is we would have repeat as the convergence function. Here we call r.length, and here we say, because there's something like length, I assume. Yeah, there's the length of a list, but this is actually of a list, right? Not of a string. I don't know if they actually can we do console log r.length of foo? Probably not. No, we can. Okay, so that's fine. So we can do length, and then we can do identity, right? Because we want to have the actual string without actually changing it. So actually, to make it a bit more interesting, let's say that these should be uppercase, like this. So then we would say to upper. Does that make any sense, right? That kind of works. And then we want to say console log rep of hello. What do we get? We get a function that expects a single argument, right? So let's think about it, because we will pass hello to length, we will then pass hello to toUpper, and then we will, here we will get 5, and here we will get hello uppercased, which means that we would get repeat 5 hello, right? That's sort of the expected value, but we don't seem to be getting that. But let's just see. N must be a non-negative number. Ah, sorry, because it's actually the other way around. Terribly sorry. It should be this, right? Like that. Because we're repeating, that's actually what I said when I read the thing, but I'm sorry. So we first pass the thing that we want to repeat, and then we pass the number of times we want to repeat it. So yeah, so here then the hard-coded example works, but here we actually get a function. So why is that? We first pass toUpper, and then we pass the length, which is the length of the string, right? And if I just say identity here, it shouldn't matter really. No, so why is this? This is a bit confusing to me. So maybe this is the whole, let me just try something, and if it works, I'll explain it. So what is that? N-array, let's just look at what the syntax of N-array is. So N-array, yeah, and then a function. So N-array repeat takes 2 arguments, and then it's this function. Does this make a difference? N-array. Yeah, that makes a difference. Okay, so this is an interesting caveat of converge. I am not sufficiently good in functional programming to understand what lift does yet, right? But from reading the issues and some of the pull requests, and actually having taken part in a pull request and an issue on the GitHub page for Ramda in regards to converge, it seems that some people are suggesting that converge should be deprecated in favor of lift, as in that anything that converge can do can already be done by lift, and lift is sort of a category theory concept. So it's very, very common in functional programming, and people are using it. So there's no need for converge. However, the caveat is that converge some kind of supports variadic functions. So sometimes this causes issues where you want to use a variadic function as the convergence function. But this also kind of confuses me that this would be such a scenario, because let's just look at this, right? I mean, R.repeat. No, sorry. What I wanted to say, I wanted to know what's the length of R.repeat. That's 2, right? So the arity of repeat is 2, but maybe the issue is that toUpper has a length of 1, and R.length probably has a length of 1. Yeah, so the problem here is that since these 2 functions have an arity of 1, Ramda assumes that the number of arguments that will be applied to the convergence function is 1. So it will actually only apply this argument. I think it's something like this, unless we specify that the arity of this function is 2, which is actually completely confusing, to be perfectly honest, right? Because let's go back here. If we only say repeat, whoa, I must have messed this up before. I'm terribly sorry. Yeah, it actually works. I'm sorry. We of course don't have to say n-array to R.repeat. I mean, that works, but yeah, we don't have to say that. We can just say R.repeat, and that works. But there is an issue along the lines of what I'm describing. I just can't remember exactly what it is. I assume it's something like, let's say some of the arguments here, let's say this function has an arity of 1, but this function has an arity of 2. And when you pass multiple arguments to rep here, you want some of the arguments applied to some of the functions, but some other arguments applied to some other functions. that could be one potential caveat, but also another one could probably be if we have r.call here, because r.call, I mean, let's think about that, right? If we say console.log r.call.length, what's the length of call? Well, call, whoops, this is of course because here we should have repeat. So the length of that is 1, right? Because how could call, let's go back to call here, how could call know, well, actually, let's think about that. Returns the result of calling its first argument with the remaining arguments, right? Because it's variadic, right? And that's, we've discussed in other episodes, right? Like the issue with a variadic function is that it makes currying very, very difficult, because how do you know when you've fully applied the function? If you've applied one argument, are you then done, or should you wait for another argument? If you then apply that argument, are you then done, or should you then wait for another argument? So that's probably why if we had call here and then some other stuff here, then we probably in some cases might have to use r.nary to fix the number of arguments that we want the final rep function here to take. Actually, now that I think about it, let's actually do this. Let's go to the Ramda repository and let's find sorry for this sidetrack. Hopefully you find this a bit interesting as well. And let's look at the so let's go to the issues, because I actually took part of an issue here. Let's go for closed issues, converge. I just want to steal the example that I used to post there. Let's see, wait, did I actually press? So search for converge. Possible inconsistency here, right? So this is a short discussion I had, and just like for the sake of clarity, awesome guys at Ramda. These guys are clearly super duper smart, and it was an interesting discussion. But the issue is now closed, and I contributed with a small portion that was added to the documentation, but now it's actually removed because I think they thought it was clear. Anyway, if you read the documentation, if you read the description of the function precisely, it actually says the thing that I wanted to add. But anyways, so here's something I tried to do, right? So let's remove this stuff. So what I tried to do is console log, let's say, converge, r.converge, r.call, so r.call as a convergence function, and then we pass some number of branching functions, and what we pass is we pass add, and then we pass add to. So what I'm trying to do here, let's think about that. It's actually maybe formatted like this to make it a bit more compact. So remember, call, the first argument that will be passed to call is the function to be called, and the remaining arguments are the arguments that are passed to the first function. So what we're saying here is that we're saying that I want to call add, and I want to call it with the result of adding to whatever I added to the convergence function. Right? So it's a bit hairy, but like, let's say I run this with 100. So actually, of course, this doesn't work, and what you have to do, as somebody points out here, is that you have to say that this is r.unary, which is the same as saying nary 1, but let's say unary, like this. Yeah, I guess that's, yeah, let's just try this out, because then you get 202. Okay, so let's think about that. What happens? Well, what happens is, let's write it out sort of clearly, right? What happens is that first we're running r.add 2, and we're adding, or actually, I mean, in a curried fashion, so like this. So we're constructing the function add 2, and then we're adding 100 to that. Okay, that's one thing. The other thing is that we're saying unary r.add. Okay, so that's a function that's expecting one argument. And then call is our convergence function. So then we're saying call with this as the first argument and this as the second argument. Okay, and then that's closed. So actually, let's console log that. This should give the same thing. Sorry, function f1, we're calling unary r dot add. Yeah, of course, because why would this even work in the other case? Wait, because add, yeah, sorry, of course. I mean, what I'm missing here is that this is, of course, since this is a branching function, and it's also applied to the value, or the value that, yeah, that since this is a branching function, it's also applied to the value that's passed into the result of the converging, or to the call to r.converge. So actually 100 is passed here as well, of course, sorry. So yeah, and then we get 202 in the first case and 202 in the second case. But what I'm a bit confused is about this unary part. Let's just remove that and see, does this still work, or do we have the same problem here? No, this actually works. So let's just, for the sake of clarity, let's just think about it as that, without the unary part here, and then let's think about the reason we need unary here when we use converge. So what we're saying is that we're saying call the function returned by adding 100, right? And think about currying, right? If you say r.add 100, let's console log that, then you get a function that's expecting one additional whoop. Again, then you get back a function that's expecting one additional argument. And as evident by, as if we pass another argument to it, you can see then we get the result of running that addition. But if you only add 100, then you get, I mean, it's partial application, so you've partially applied the function add with 100 so that you have a new function that's expecting another number. So that's the function that we want to call, right? And what do we want to call it with? Well, we want to call it with the result of adding 2 to 100, okay? So this will yield 102, and this will yield, let me say, f1, a function expecting one additional number. So it will yield 100 plus x, and this x will turn out to be 102. So then we get 102. I mean, we add 102, right? And then we get 202. And that's why we end up with 202 here. So that's what I was trying to do here. And for some reason, then, we can't do it using converge without specifying unary here. Let's remove that and let's run it. Then you can see that we get back a function, right? And let's actually ask, what is the length of this function? I'm a bit curious. Yeah, the length is 1. But what is the reason? Yeah, what is the reason for this? So the reason for this is something along the lines, let's actually see. I mean, I wrote an answer here. Sorry, let me just let the cat in. Wait. Sorry about that. Okay, so actually, let's read what I wrote here. So what I wrote here is that I said that, okay, I find converge, no way, blah, 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 okay. However, I now understand that the crux of this matter is that users might want to partially apply the function returned by converge. Ah, okay. So what we're saying is that the result of running converge, right? Remember, when we run converge like this, we get back a function. And the issue is then that we might want to partially apply that function. We might want to get back a function that's curried, okay? So, and in other words, the function returned as per the documentation has the signature A to B. Yeah, so because we haven't looked at the signature yet. But yeah, you get back a curried function and not like a normal function, quotation marks normal function. Or rather, you don't get back a function with an arity higher than 1. So what I'm saying is that, so if I'm not mistaken, this ambiguity is avoidable. And what I mean then is that the need for, the need to use something like unary or n-ary is unavoidable, because there are two alternatives here. Okay, either the return function is variadic and not curried, which means that both example 1 and 2 in this issue, which is the stuff that I outlined here in the beginning, that they would work since there would be no assumption regarding the arity of the function returned by converge. But then variadic and not, yeah, but then not curried. So that means that you would not have this scenario, but you would have this scenario. So you would not be able to get back a partially applied function or a partially applicable function. Right, you would not get back a curried function. Or as currently, Converge assumes that users might want to partially apply the returned function and thus makes the assumption that the number of arguments needed is equal to the longest function of the branching functions. This makes the second example of the issue fail since add is only partially and not fully applied when 10 is passed to the function returned by Converge. Let's think about that. Why is that? So Converge assumes that users might want to partially apply the return function and thus makes the assumption that the number of arguments needed is equal to the longest function of the branching functions. Yeah, so this function requires 2 arguments. So they're going to assume that call requires 2 arguments. This makes the second example of the issue fail since add is only partially and not fully applied when 10 is passed to the function returned by Converge. I'm confused. This makes the second example of the issue fail since add is only partially and not fully applied when 10 is passed to the function returned by Converge. Second example of the issue fail, add is only partially not fully. Yeah, so this needs to be applied to 1 additional argument. This needs to be applied to 2 arguments. But I'm also saying that the number of arguments needed is equal to the longest function of the branching function. So this should actually be 2. So the assumption should be that r.call, or rather, sorry, not r.call, but the result of okay, sorry, that's the issue, right? Yeah, okay, actually, let's try that. If we pass 20 here, just for the sake of, yeah, okay, but maybe then that's not a function. But the assumption is that the result of Converge, the arity of the thing that we get back from Converge, or not as in arity, but as in the number of arguments that we need to apply before the partial application is completed, before we have a fully applied function, is equal to the length of the longest function, like the arity, the highest arity of the converging functions. And the arity, the arity of this function is 2, and the arity of this function is 1. And if the arity of this function is 2, then we're going to assume that Converge needs to be applied to 2 arguments. Okay. Pause for reflection. Whew, so much confusion, which actually makes perfect sense, right? Because if we think about let's say now we're in kind of a contrived scenario because we're using Converge and we're mixing it with call. But if we're using it in a less strange way, like if we're using, let's go back to Converge here. So let's go to Converge and let's say like what they were doing here, right? The strange concat. When you had 2 upper, 2 lower, and then concat, right? So so they're saying r.converge, the convergence function is concat, and the branching functions are upper or 2 upper and 2 lower, right? Concat is a binary function, right? It takes 2 arguments. Its arity is 2, but 2 upper and 2 lower are both unary functions, right? And the fact that they are unary function then dictates the fact that what we get back from this running of Converge, like the function that they call strange concat here, its arity will of course be 1, right? Because this string yodel will first be passed into 2 upper, then it will be passed into 2 lower, and then these 2 arguments will each be passed into concat. So I was kind of saying this incorrectly before when I was saying that like the highest arity of the branching functions determine the length of or the number of arguments that will be passed to call. That's not true, right? Of course, the number of arguments that will be passed to r.call in this example here, it is of course 2, because we have 1 branching function here and 1 branching function here. So it's obvious for Ramda, like we have a list of 2 things, so these 2 things are things that should be passed to call. That's fine, right? That's not the issue. However, the issue is that add here is actually never applied to enough arguments, or yeah, let's think about it. Add, we pass 2 or we pass 100 into it, and then supposedly we should be passing 2 into it. But we'll probably never get to that point, right? Because converge returns a function that's expecting 2 arguments. Because the length of add here is 2. So they're assuming, like, when we're constructing the function that's returned by converge, I mean, we could do this maybe just to make it a bit more clear. We could say const f is equal to, like so, right? And then say console log f applied to 100. So when we're constructing the function f, the arity of the function f will actually be 2. And this we should actually be able to see this, right? Console log f dot length, let's say. Yep, and the arity of that function is 2, because the arity of add here is 2. So of course it's expecting us to apply it not just with 100, but with something else here. But then we blow up, because then so this doesn't really line up, because then we've passed too many arguments here, and I'm not even like let's not dig into actually what went wrong in detail. But that's obviously not what we're actually aiming for. But what we can do is we can trick quotation marks Ramda by saying that let's treat r.add as a unary function, right? Because then the arity of f will be 1. The arity, so this f.length, that actually returns 1. And then we get 202 as a result. Then we actually, I mean, let's think about it. We take 100, we pass that 100 through the unary version of add, right? So producing a new function that have been applied to 100 and is waiting for another number. So rather, producing a new function that adds 100 to whatever we pass it. And then we have this function which is already partially applied to 2, so it adds 2 to whatever we pass it, and that's going to be passed 100. So this is going to result in 2 plus 100, and this is going to result in a function, well, actually, I mean, it's like, yeah, it's going to be 100 plus whatever we pass it then, and what we pass it then is going to be 2 plus 100, because it's going to be this line, right? Because we're using call, so yeah, we're actually, I mean, yeah, it's a bit sillily explained of me, right? But on this line we have a function that expects 2 numbers. Here we have a function that expects 1 number. But when we apply 100 to this, right, after we've applied 100, then here we have a function that is partially applied with 100. And after we've applied 100 here, we don't have a function, we have 102, right? But here we have a function that adds 100 to whatever we pass it. And since we're using call, then like the whole converge thing will be that we pass we call this function that we have here, which is add 100, right? Which is essentially r.add 100, right? That's the thing that we have here, and we pass this next argument to that function. Okay, so much confusion. Sorry about this. Let's just see if we can make this a bit more complicated. Let's see, can I add 10, 20, 30? Can we do this? 30, 10, 20. No, we can't. Okay, but can you construct? Yeah, probably not. Like an array 3 r.add. No. So I'm just trying to think if we have an example of something which takes multiple arguments. Maybe some native JavaScript functions, right? Like not concat, but yeah, I mean, you can probably think of think of something on your own as well. But what I was trying to get at is, of course, we could add more functions here if we had a function here which took more arguments, essentially, right? But yeah, okay, so this I feel was an extremely confusing explanation of what the function converge actually does. We're going to read the type definition in just a moment, but let me just say that I think that this was kind of like I somewhere along this video decided just to keep going instead of pausing and sort of redoing it. Let me know if you think it was useful to follow like my line of thought and the way we sort of understood this function together, or whether you think this was a complete waste of time, because that helps direct future videos. But anyways, let's read the type definition, because actually, I mean, this type definition looks like some serious mumbo jumbo, but it's actually probably not that strange, right? So let's first look at the bigger picture. What closes this parenthesis? Here we have one sort of block. Here we have one list, right? That's a single list. Yep. And this is the result. Right, so it's actually not that strange. Here, this is argument 1, this is argument 2, and this is the result. And given the information that we know now, we can actually read this. This is the converging function. So this is the type definition of the converging function. And this is the list of all of the branching functions. And then this is the result of running converge. So in our case, it's the thing that we called f here, for example. So what's the definition, or what's the type of the converging function? Well, the type of the converging function is that if you pass it some x1, some x2, like it's variadic, right? Could have any arity. You get back some z. Okay, so that establishes some types. Let's see if those are used again. Okay, here x1 is used and here x2 is used. Is z used anywhere? Yeah, z is used here. Okay, so think about it. The converging function will produce some final z. And that is the same type that we see in the end, right? So converge will produce some function that we in our example called f here, and the final return type of that function will be of type z. And that's the same type as the return type of the converging function, of course, right? Because that's the function that we use to condense everything down into a single value, or converge into a single value. And then let's see, we have x1 and x2, and those are also used here, right? So, because the converging function, this is actually pretty interesting. Like you can read a lot from this type definition actually, or this type signature. So the first argument that's passed to the converging function is of type x1. The second argument is of type x2, right? And these are actually the results of the first branching function and the second branching function, right? So the first branching function takes some a's, some b's, and so forth, and produces something of type x1. The second branching function takes something of type a, type b, and so forth, and produces something of type x2. And then that thing of type x1 is passed to the convergence function. Hence, like, this is why we can see x1 here. And the x2 that's produced by the second branching function is the second or is the same type as the thing that's passed to the converging function as the second argument, right? So you can see how those things line up. But then that's not the only thing that lines up. What's also interesting is that here you can see this repetition of a and b and so forth. Like that's the arguments that are passed as input to the branching function number 1. Or to branching function number 2. But that's the same thing that's passed to branching function number 2, a and b and so forth. And those things are then repeated here in the input to the resulting function. Again, this function that we called f, which is the function that's produced by converge. So you pass a and you pass b and you pass so forth, right? Those are passed both into the branching function number 1 and into branching function number 2. Branching function number 1 produces something of type x1, branching function number 2 produces something of type x2, and those things are passed into the convergence function, right? x1 is the first argument and x2 is the second argument, right? So this actually contains tons of information, right? You actually get quite a lot from this, and this probably makes it more clear why we had this issue of having to force add to become unary here, because that's maybe the way I should have explained it. Because this function has an arity of 1, then this function should also have an arity of 1, right? Because otherwise call is going to assume that if this is longer than 1, if this has a longer arity than 1, then why then we need to apply f to multiple arguments, to as many arguments as this expects, in order for the converge to be completed, in order for it to be fully applied, right? I mean, I was thinking that this is possibly more evident since we can see here that the function produced by converge is something that takes an a and a b and so forth, and that a and b is repeated both in the first branching function and in the second branching function. So they should be somewhat symmetrical, like on a type basis. But then, I mean, because we're in a dynamic language, we can sort of do a bit of funky stuff. But yeah, that should hopefully make that a bit more evident. That's also like one final thing. Sorry, the last final thing, and then I'll give this up, right? You could, of course, I'm just trying to think that like their second example that they have, the second example that they have here is also numerical, and like you could probably that would possibly be scenarios that are a bit more useful. Actually, I just realized maybe we have, doesn't JavaScript have like a max method? Do we? No. Math.max? Yeah, we do. Okay, math.max of 10, 20, 30. Excellent, that's 30. So this is variadic, right? 40, let's put 100 here, and then a bunch of more numbers. Yikes, wrong buttons. Okay, yeah, so that actually works. Okay. So what we could do is we could do something like this: const f r.converge, and then let's say math.max, and then we're converging on the basis of max. And then we have a bunch of functions here, and then maybe as what they are doing, right? Like we do something like r dot length, r dot sum. I don't know, like a bunch of other. I wish we had like, yeah, but maybe they do have average. No, maybe JavaScript has average. No, of course it doesn't, right? Average. Yeah, of course not. Of course we don't have mean. But anyways, let's assume that we had mean, that we could do something like that, right? Like, so let's not run it, right? Like, but let's say, let's actually do this. Let's say we had standard deviation. Let's say we had mean. Let's say we had max. Let's say we had, actually not max, but like mode and actually that's silly. Let's say mean and mode. Why can't I? Yeah, so okay. This makes no sense. Sorry, I'm just doing a bunch of stupid stuff. The length and let's say the length and the sum and the largest number. Let's say because this we can actually try. So I don't know why I started to make my life any more complicated than that. So this seems to work out fine. And then let's console log f on 1, 2, 3, 4, 5, 6, and 7. And then we can see that we get back undefined. ¿Por qué? Sorry, this is, I mean, I should run it like this. Yeah, my bad. Then we get back a function. Length 1. Because max takes a number, so it's actually not the max from the list. So maybe that's r dot reduce. Max from 0, something like that. Yeah. So this we'll talk about some other time, but if you're familiar with reduce, this probably makes a ton of sense. But that's just saying like the largest number in the list. Right? Which is actually, actually we could probably use math.max here. That would be some kind of the same thing. No. Yeah, that would not be the same thing, apparently. Anyways, let's not think about that. Yeah, okay, sorry, because I'm passing them as a list and not as a bunch of arguments, and this is why. Like, so math.max is variadic, but we're actually passing a single list here. So it was a single argument, and this is why we need to reduce over that. Whoa, longest useless example. What I'm trying to say is that now we're passing a bunch of data into this function f that we've produced. We do a bunch of analysis, right? Like we compute a bunch of things, such as the number of things in the list, the sum of the things in the list, and the largest number in the list. And then we take the largest number of all of those three numbers, right? So like, is the length the largest thing, or is the sum the largest thing, or is the largest number in the list the biggest thing? So I don't even know which one it is, 28, but like, yeah, okay, so it's not the length, it's possibly the sum, and it's not the largest number. So yeah, it's the sum. But like, if we had a bunch of ones like this, no, actually, sorry, not ones, but probably zeros like this. Actually, that's a bit silly. If we have a bunch of zeros like this, then the length is the largest number. So anyways, I mean, this, I understand, is also a completely useless example, but hopefully you can see how you can use converge to derive or to perform quite complex computation in a very condensed manner, and often in a point-free manner. Like you can convert a point style, or from a point-full style to a point-free style, kind of trivially. Okay, I promise, the next time I talk about converge, I'll prepare an example. But again, please let me know if this was actually still useful anyway, or if this was a waste of time. Anyways, thanks a ton for watching. I will see you in the next Ramda video, and I promise that one will be shorter. Thanks for watching. I'll see you in the next one.